Okay, let's dive deep. Think about gravity for a second.
Yeah.
We feel it. We use it to predict satellite orbits with incredible precision. But what is it, at its most fundamental level?
Right, that's the core question.
For centuries, humanity's understanding has shifted from invisible pulls to, well, warped geometry.
Mm-hmm.
But even our most brilliant ideas left some big questions hanging in the air. Or maybe hanging in the vacuum of space.
That's exactly where our deep dive takes us today. We're exploring a fascinating set of documents titled Quinta Essentia, a practical guide to space-time engineering.
Quintessentia, okay.
Yeah, and this isn't your standard physics textbook. It proposes a fundamentally new perspective on gravity and inertia.
How so?
It tries to tie them directly to the quantum vacuum and electromagnetism, and it offers a new set of tools it calls electrogravimagnetics, or EGM.
EGM. Got it. So our mission today is to unpack this ambitious work for you. We'll look at the historical mystery of gravity, this proposed solution, EGM, and some truly, well, astonishing claims the sources make about what EGM reveals.
And these claims span from the smallest particles to the structure of the entire universe. It's quite broad.
Okay.
We'll guide you through the core ideas presented in these documents, highlighting the most intriguing insights.
Great. So let's rewind a bit. The story of understanding gravity really kicks off with Isaac Newton, doesn't it?
Absolutely. The Principia, monumental work.
His mathematical formulas were revolutionary. I mean, they're still the foundation for sending probes across the solar system today.
Incredible precision. And Newton described gravity as a force, right? A pulling effect transmitted instantly across vast distances.
That whole action at a distance thing.
Yeah, which even Newton recognized was a bit mysterious. How could a force just act across empty space?
Right. Did he have an explanation?
Well, he and many others at the time speculated that space wasn't actually empty.
Ah, the ether.
Exactly. They imagined this substance, the ether, a kind of invisible fluid or medium that filled everything and, transmitted this gravitational pull.
But that ether idea, it created a logical problem, didn't it?
It sure did.
If space was filled with a substance, some kind of fluid, shouldn't planets and stars be pushing through it, experiencing resistance?
Right. They should be slowing down eventually. But that didn't seem to be happening.
So Newton wrestled with this.
He did. And it's interesting, in his later work, Optics, he speculated something else.
Oh.
Maybe gravity wasn't just a pull transmitted by a fluid, but perhaps more like optics.
Optics, like light.
Yeah. Maybe the ether had different densities or properties around matter acting like a lens, causing both light and objects to bend their paths.
Huh. That's a fascinating bit of intuition, hinting that gravity might be an optical effect.
It really was. Now, fast forward about 200 years, and Albert Einstein gives us general relativity, or GR.
Okay, a completely new paradigm.
Totally. And it's based on observing how light itself bends near massive objects. It's fundamentally a geometric view of gravity.
So instead of a force pulling things,
GR says mass and energy actually warp or curve the very fabric of space-time.
like the heavy ball and the stretched rubber sheet analogy.
Exactly that. The sheet curves and other smaller balls rolling nearby just follow the slopes.
So objects in space, planets, light, they simply follow the natural slope of this curved spacetime.
Precisely. And this elegant geometric picture, it neatly solved the action at a distance problem.
How so?
Because motion isn't caused by some distant pull, it's guided by the local shape of the space-time fabric itself.
Ah, so the old ether concept, which had kind of fallen out of favor
It
anyway.
just seemed unnecessary. It just vanished from the picture for a while.
But GR, while brilliant in describing how gravity behaves, it sort of introduced a new mystery, right?
It did. What is this space-time fabric that's doing the curving?
Yeah, how can nothing, what looks like empty space, have a shape or a curvature?
That's the crux of it. The sources we're looking at point out that curvature in GR is a powerful mathematical tool, a contrivance, as they call it.
A contrivance.
Yeah, meaning it describes what happens incredibly well, but it doesn't really provide a physical process for how space-time is affected or how that effect is communicated to light and matter, telling them which path to follow.
So we replace one mystery, how gravity acts across distance, with another. What exactly is bending? You got it. And this is where modern physics, particularly the view from quantum mechanics, offers a really crucial insight that starts to bridge the gap.
Okay, QM. That tells us that the empty vacuum of space is actually anything but empty, right?
Absolutely. It's described as a seething, chaotic sea of energy fluctuations.
It's like static on an old TV, that analogy.
It's a crude analogy, but yeah, something like that. That random noise gives you a feel for the quantum vacuum, buzzing with potential energy everywhere, even in the deepest voids or the tiniest spaces inside an atom.
So the vacuum isn't just nothing. Not in the quantum view. It could be a something, a kind of underlying matrix or substance, maybe something that could support the abstract curvature of GR, or perhaps something more, well, physical.
Oh, there's a connection to inertia, too.
Yes, a key observation highlighted in these sources is that both gravity and inertia, that resistance you feel when you accelerate, seem to originate instantaneously from this vacuum.
Instantaneously.
Yeah, hinting at a deep shared connection between them and this energetic quantum backdrop.
Okay, so this idea of the vacuum as a physical medium, sort of putting the something back into space, that led to new models.
It did. One notable example mentioned is physicist Hal Puthoff's polarizable vacuum model, or PV model, from 2002.
Polarizable vacuum, PV.
And this is presented as an alternative way to interpret GR. It basically replaces the abstract space-time curvature with a more physical idea, a variable index of refraction in space around matter.
Index of refraction, like optics again, like light bending when it goes through water or a lens.
Exactly like that. The speed of light changes depending on the material that's its refractive index.
Okay.
In the PV model, matter polarizes the vacuum, causing its properties, specifically its refractive index, for space-time to change in a gradient around it.
So light bends towards massive objects because space itself is acting like a giant lens with varying optical densities. Is that the idea?
That's the core idea, yeah. It offers a more physical picture than just abstract curvature.
Right. It suggests how space might be affected by matter and how objects might sense a gravitational field through changes in this refractive medium.
It's definitely a step closer to Newton's later optical intuition, wouldn't you say?
Yeah, it does feel like it circles back in a way. Okay, so PV provides a more physical optical frame, moving beyond abstract curvature. But as the sources point out, it still leaves us asking some questions.
Like what?
Like, how does matter cause this change in the vacuum's refractive index? What's the mechanism?
Right. And also, why does space becoming refractive translate into what we experience as a gravitational force? Where does the force come from? Exactly. And this is precisely where the source material, Quinta Essentia, proposes its answer. Electrogravimagnetics, EGM.
Okay, EGM again. How does it answer those questions?
Well, EGM is positioned as extending the frameworks of both GR and QM, but crucially, it also brings in principles from thermodynamics and engineering.
Engineering. That seems like a departure from fundamental physics.
It is, and it's actually key to the EGM approach described in the sources. EGM proposes that matter doesn't just passively warp or polarize space, it actively does work on the quantum vacuum.
Does work, like energy exchange.
Exactly, an energy exchange. And this exchange, according to EGM, is fundamentally electromagnetic in nature.
Electromagnetic. So the interaction isn't some mysterious pull or geometric effect, but an EM dance with the vacuum itself.
That's the core claim. EGM models this EM energy exchange thermodynamically, like matter establishing an energetic equilibrium with the vacuum around it. And this process, this EM work being done, is what changes the vacuum's configuration. And importantly, this change isn't just described as abstract curvature, it's the vacuum becoming refractive, aligning with that PV model.
Ah, okay. So it provides the how for the PV models what?
Sort of, yes. And here's where it gets really interesting and perhaps a bit counterintuitive if you're steeped in traditional physics.
Come on.
The sources state that EGM demonstrates that gravity itself isn't a fundamental force like electromagnetism or the nuclear forces.
Not fundamental. Then what is it?
Instead, gravity is shown to be a byproduct of this ongoing electromagnetic exchange between matter and the surrounding quantum vacuum.
A byproduct. Wow. What about inertia?
Inertia, too. That feeling of resistance to acceleration is also proposed to be another EM byproduct of this very same interaction.
So gravity and inertia are emergent phenomena.
That's the paradigm shift presented. They aren't primary forces. They emerge from how matter interacts electromagnetically with the underlying vacuum.
Okay, hang on. How does that square with GR? GR works incredibly well.
It does, and EGM doesn't discard GR. It claims objects and light moving through these regions where the vacuum has been made refractive via this EM exchange, they follow paths according to optical principles.
Fraction, like we said.
Exactly. And those paths end up behaving exactly as GR predicts, but EGM provides a physical mechanism underneath the geometry.
So EGM aims to show how GR's geometry and QM's vacuum energy are linked through electromagnetism, like a unifying principle.
Precisely. It aims to reveal a single, universal principle applicable across all scales, subatomic to cosmological, showing how gravity, inertia, and the vacuum are all manifestations of the same underlying electromagnetic reality.
Okay, this brings us back to the engineering tool aspect you mentioned. How does that mindset shape EGM?
Well, think about the different approaches. Traditional fundamental physics often takes a reductionist path, break things down to the simplest bits and forces.
Right, find the elementary particles, the fundamental laws.
Engineering, though, often takes a more inductive approach. You observe a phenomenon, you understand the principles governing it, and then you integrate those principles to build something, or maybe even reverse engineer a system.
And EGM applies this engineering mindset to gravity.
That's the claim. Like reverse engineering gravity itself, in a sense.
Oh.
It applies conventional, well-understood engineering principles, particularly thermodynamics, to model gravity. It sees it as a system where matter interacts to achieve thermodynamic equilibrium with the quantum vacuum.
And that interaction is electromagnetic.
That interaction is electromagnetic, yes.
So what's the goal of using this engineering methodology? Why frame it that way?
The stated goal is to provide a mathematical framework that doesn't just describe gravity geometrically like GR does, but represents the PV model, the vacuum's refractive properties in measurable, quantifiable electromagnetic terms.
Measurable EM terms.
Okay. The sources state this allows for calculations, predictions, and critically aims to make this physics useful for practical applications.
Useful how?
This is where the idea of space-time engineering comes directly from the source title. Putting GR into a format that enables invention, not just description.
Space-time engineering.
Yeah.
Yeah, that still sounds very sci-fi. But you said the sources make some pretty bold claims about what EGM, using this engineering approach, has actually been able to derive and predict.
Extremely bold claims covering massive scales.
Okay, let's get into specifics. What about the incredibly small world of particle physics first?
Right. This is one area where the sources highlight some, well, astonishing results. EGM is claimed to achieve a kind of quasi-unification in particle physics.
Quasi-unification. What does that mean?
It suggests that fundamental particles aren't just random entities, but can actually be described as harmonic multiples of each other.
Harmonic multiples, like musical notes. Different notes on a string vibrating at related frequencies?
It's presented conceptually like
Right.
that, yeah. Like resonant frequencies or stable structures within the vacuum, suggesting a deep underlying order.
And EGM can calculate particle properties based on this.
The sources claim it can calculate highly precise physical properties, masses, radii for a whole range of fundamental particles.
Right.
Protons, neutrons, electrons, muons, tactus, their neutrinos, quarks, even the force-carrying bosons, the photon, and the graviton.
And these calculated values, do they match experiments?
The sources state that these calculated properties frequently match experimental data from leading labs. PDG, ZUS, D0, SNO are mentioned often to very high precision.
Wow, okay. What else in particle physics?
They mention deriving fundamental constants like the fine structure constant from the model.
That's a big one.
It is. And effects like the Casimir effect are said to be derived from EGM's vacuum model. It even suggests specific experiments to test aspects of its theory, like something called a negative energy conjecture.
Negative energy. Interesting. Any other derivations?
It also apparently provides derivations for fundamental scales, giving experimentally implicit definitions for things like the Planck scale and the Bohr radius.
And it can reproduce things we already know, like atomic spectra.
Yes, reproducing the hydrogen atom spectrum, the Balmer series, is mentioned as another result.
Okay, deriving known things is one thing, but does it predict anything new?
It does. That's another major claim. Based on its harmonic model, EGM is claimed to predict the existence of new, currently undiscovered particles.
Really? What kind?
Specifically, 3 new leptons or neutrinos and 2 new intermediate vector bosons.
So testable predictions, that's crucial.
Absolutely. If those particles were found, it would be huge validation.
Okay, that's quite a list for the subatomic world. Let's zoom out now, way out, to the vastness of cosmology. What does EGM have to say about the universe on the largest scales?
The sources state EGM has been applied to key cosmological parameters with results they describe as equally astonishing.
Such as?
It claims to derive the Hubble the measure of the universe's expansion rate and also the temperature of the cosmic microwave background radiation.
The CMBR, the afterglow of the Big Bang.
Exactly. And the derivation of the CMBR temperature is highlighted as a particularly significant point of validation in the sources.
How close is it?
The claim is that EGM's derivation, around 2.7248 Kelvin, falls astonishingly close to the current experimentally measured value, which is 2.725 plus or minus 0.001 Kelvin.
That is remarkably close, if accurate. Does EGM also derive things like the universe's age, size, mass, density?
Yes, those are mentioned too, along with characterizing the universe's evolutionary history according to its principles. And maybe one of the most striking cosmological claims relates to dark matter and dark energy.
The big mystery. The stuff thought to make up, 95% of the universe's total mass and energy?
That's the standard picture, yes. According to the EGM sources, the observed accelerated expansion, usually attributed to dark energy, is tied to the zero-point field energy density threshold of the vacuum within their model.
Okay.
But here's the really controversial part. EGM suggests that the majority of what cosmologists currently classify as dark matter and dark energy is actually photons.
Photons, you mean light. Hang on. So this model is saying most of the universe's missing mass isn't some exotic, unseen particle or strange energy field, but just light. That's a radical departure from standard cosmology.
It is a very, very bold claim represented in the sources, yes. EGM calculates that photons constitute over 94.4% of the total mass energy of the universe, according to its model.
Over 94.4% photons.
That's the number given. It also claims EGM calculates that the actual impact of what is typically defined as dark matter energy on parameters like the Hubble constant or the CMBR temperature is less than 1%.
So EGM basically says the standard model is wrong about dark matter and energy, that it's mostly just photons being interpreted differently.
That seems to be the implication presented. The sources attribute the apparent discrepancy to EGM's recharacterization of the vacuum and the nature of energy and mass within this different framework.
So they're saying EGM offers an alternative explanation for the observations that lead us to infer dark matter and energy. Like, the standard model is misinterpreting the data.
Essentially, yes. They're saying the standard model lacks the EGM framework, leading to the inference of these dark components, which EGM says are predominantly photons.
That's a massive claim. Does it explain why we seem to detect dark matter gravitationally in galaxies and clusters then, if it's just light?
The sources suggest EGM's view of gravity as an EM byproduct interacting with the vacuum accounts for these observations without needing exotic dark matter particles. They also mention deriving the characteristics of Schwarzschild black holes within this framework.
Wow. Okay, that covers a huge amount of ground, from tiny particles to the whole cosmos. But let's bring it back down to Earth, or, back to the listener. Why should you, listening now, care about these abstract ideas like the quantum vacuum, refractive indexes, or particle harmonics being tied to engineering?
Well, the sources argue very strongly that EGM isn't just theoretical speculation. That's the whole point of the engineering angle. By reframing gravity and inertia in terms of tangible, measurable, electromagnetic interactions with the vacuum, and using that engineering methodology, the stated goal is to transition these fundamental physics concepts into practical applications.
Practical applications.
Yeah.
Like the space-time engineering in the titles.
Exactly. Moving from just understanding how space-time is curved or refractive to figuring out how we might actively manipulate it.
Manipulate space-time. We're back in sci-fi territory again.
It sounds like it, doesn't it? But the sources position EGM as a potential framework, a mathematical toolset that could, theoretically, enable technologies we usually confine to science fiction.
Such as?
Things like localized gravity modification are mentioned, or even superluminal propulsion systems.
Oh, gross.
What many people think of as warp drive, yes. The underlying aim described is to translate general relativity from a purely descriptive theory into an inventive, practical toolset.
An ambitious goal, to say the least.
Extremely.
Okay. We've certainly taken a deep dive into these quintessential sources today. We've traced the historical quest to understand gravity, from Newton's puzzling ether,
And Einstein's abstract, curved spacetime.
peered into the surprisingly energetic quantum vacuum.
And explored EGM, this new model proposing that gravity and inertia aren't fundamental forces at all.
Right. But optical electromagnetic byproducts of matter's interaction with that vacuum.
An interaction framed using engineering and thermodynamics.
And this approach, it's claimed, yields stunningly precise calculations across physics scales, from particles to the cosmos.
And offers that radically different view on the universe's composition, especially regarding dark matter and energy being mostly photons.
It's definitely a perspective that challenges conventional thinking, trying to unify major areas of physics under this single underlying electromagnetic principle tied to the vacuum.
It really does.
And it leads you, the listener, with a truly provocative thought to chew on. If gravity and inertia are simply emergent properties, byproducts of matter interacting electromagnetically with the quantum vacuum, does that fundamentally change our understanding of what empty space really is?
And what incredible possibilities might open up if we could actually learn to manipulate that fundamental interaction, if we could engineer space-time.
And what does it mean if most of the universe's unseen mass and energy is, in fact, just light, viewed through this different lens?
It really makes you wonder.